Hello dear students, I am Govind Lohiya, working as Assistant Professor, Guru Nanak College of Pharmacy, Nagpur. The topic is Solubility of Drugs is prepared exactly according to the PCI syllabus. In third semester, Physical Pharmaceutics I is the subject, and in that subject, very first topic is Solubility of Drugs. I am here to cover the entire topic of solubility of drugs. The video may be more than 3 or 4. In the first video, I am just going to cover the basic aspect of solubility, solution and solute, and solubility expressions and mechanism of solubility. According to syllabus we are going, and if there is any problem in the video content or in understanding, you can post me in a comment box. I can reply you to that comment. So let's start with the solubility of drugs. So objective of the chapter, after completion of this chapter, you must be able to understand the various types of pharmaceutical solutions, define solubility, saturated and unsaturated solution, and polar and non-polar solvent means what, explain the role of diffusion principles in biological systems, Rawls law and derivatization, understand the factors controlling the solubility of strong and weak electrolytes, define partition coefficient and its importance in pharmaceutical system, because all these parameters are very responsible for any pharmaceutical dosage formulation. And this topic is important in terms of your GPAT examination, in terms of your further competitive examination also. Okay. So understanding phenomenon for any pharmacist helps to select the best solvent for the drug or mixture of drugs. Consider you are a formulation scientist in future, and you need to solubilize drugs which is poorly soluble. So this solubility aspect you make a competent enough that you can choose a best solvent for the solubility. Overcome the problem arising during the preparation of the pharmaceutical solution. There are so many problems, that is precipitation, stability issues, and you can overcome with the help of solubility aspects. Have the information about the structure and intermolecular forces of the drug and their diffusion through a biological membrane. Many drugs are formulated as a solution or added as a powder or solution forms to liquid. So you have sound enough knowledge about the solubility and solution of a drugs in a particular solvent. So even that some drugs having a very low aqueous solubility and they might be cause dissolution problems. So you can be able to justify, you can able to apply your knowledge of solubility concept over there. So start with the topic. So some definition, solution. So very first definition of the solution. Solution is nothing but solution is a mixture of two or more component that form a homogeneous mixture. That is, it is two or more than two components that form a homogeneous mixture. The components are referred to as the solutes or solute or solutes, because more than two, that it refers to solutes, and the solvent and solvents. It doesn't mean, it means that sugar and water, sugar will be act as a solute and water will be act as a solvent over here. Sometime sugar and a tea powder, or what we say, sugar and salt. Sugar and salt both act as a solute and water will be act as a solvent. Now if I am going to add some colorant, liquid colorant, okay, so liquid colorant is again one more component over here. So you can add as many as, but provided that this can form a homogeneous mixture. It can form a homogeneous mixture. So solution is a mixture of two or more components that forms a homogeneous mixture. Okay, clear? Over here, a diagrammatic representation, the solute is added to the solvent. Then over here it can be uniformly distributed among the solvent and forms a homogeneous mixture, and ultimately the solution is made. Okay, now concept of solute and solvent. Again I am saying that solute, the substance usually present in the lesser amount and getting dissolved in the solution, and solvent is the subcomponent in which the solute is dissolved Usually it is in a greater amount. Now solubility. So solubility is a quantitative term and qualitative as well. So in qualitative way, if we are going to define solubility, it is the concentration of solute in a saturated solution at a certain temperature. So it is a concentration of solute in a saturated solution at a certain temperature. It is quantitative way to define the solubility. In a qualitative way, it is the spontaneous interaction of two or more substance. That is, what are the two or more substance? Solute or solutes, and solvent or solvents, okay, to form the homogeneous molecular dispersion. So qualitatively, it is a spontaneous interaction between two or more substances, that is solutes and solvent, and quantitatively, that means we can measure in a quantitative way that how much amount of sugar is dissolved in a water at its saturation point at a given temperature. So we can say that 10 gram of sugar is dissolved. So this 10 gram is quantity, and qualitative is nothing but it is spontaneous reaction between sugar and water. That's it. So this is, we can define solubility in quantitative as well as qualitative way. Now this is important. Solubility is the intrinsic material property of the molecule. While when we're talking about the solubility of drug, you can talk about the solubility is definitely intrinsic material property. You can't change the solubility of the drug. But while the dissolution is extrinsic material property, what does it mean? That is, definitely if the paracetamol dissolve or boric acid dissolve 2 mg per 100 ml, I am not able to change the solubility of boric acid 2 mg per 100 ml at room temperature, but I can modify the solubility of boric acid by incorporating the boric acid into certain component, by combining boric acid with the certain powder. So we can modify the dissolution of boric acid, but we cannot change the solubility. That is because solubility is intrinsic material property, while dissolution is extrinsic material property. It can depend on the other part. Apart from that drug, it can be modified. So solubility is intrinsic and dissolution is extrinsic material property. Solubility of drug depends on the physical and chemical properties such as temperature, pressure, pH of the solution, state of the subdivision of the solute. So solubility depends on so many parameters. That is the boric acid. Let's come with the same example of boric acid. Boric acid soluble in water at so and so temperature, that is 2 mg per 100 ml. If I am going to change the pH, because it is acid, I am going to change the pH to the base, then definitely the solubility goes on increasing. If I am going to change the pH, then definitely solubility goes on change. Not only this, if I am going to change the pressure, there is a change in the solubility. Okay. Now thermodynamic solubility of the drugs. In the entire this topic, we are majorly talking about the thermodynamic solubility of the drugs. So what do we mean by thermodynamic solubility of the drug? If we talk about thermodynamic solubility of drug, in a solvent is a maximum amount of the most stable crystalline form that remains in a solution in a given volume of a solvent at a given temperature and pressure under equilibrium condition. Let us see one example, simple example. What I am trying to say, crystalline form, most stable crystalline form, it is considered, this is the example, again this is example, considered a boric acid example. If I am or benzoic acid example, if I am going to add crystals of that, it is try to solubilize into the solvent at a particular temperature in the beaker. Now it remains in a solution in a given volume of solvent. That means it, whatever the crystals I have added, it remains in a solution form at that temperature in that particular volume is, and whatever the pressure, it is 1 atmospheric pressure because it is open. So at that pressure under equilibrium condition is to be called as thermodynamic solubility of the drugs. Now I can change this one. If I am going to increase the temperature, no doubt the most of the compound as we goes on increasing the temperature, they shows the mole solubility. same beaker, same solute I am using, I am going to increase the temperature, the solubility goes on increasing. And as soon as if I am goes on decreasing the temperature, whatever the excess solute I have added, it goes on crystallization. You can see in that test tube there is a crystallization process. It is as soon as it is you decrease the temperature, there are so many aspects, there are so many ways to how to go for the supersaturation. Then after supersaturation, if I am going to decrease the temperature, then it shows the crystallization. So there are again two definitions. So thermodynamic solubility is nothing but the most stable crystalline form in a given volume at a given temperature at a given pressure, in it is in the soluble form in equilibrium condition. So these words need to become in a thermodynamic solubility. What the words in thermodynamic solubility? Given volume, given amount of solute, given temperature, pressure and equilibrium. These terms must be included in your thermodynamic solubility definition. So saturated solution, a solution that contains the maximum amount of solute at a definite temperature. So beyond that you cannot be able to dissolve any further addition of solute. So this is nothing but the saturated solution. Unsaturated solution is nothing but, that is the solution is one containing the dissolved solute in a concentration below necessary for the complete saturation at a definite temperature. That means the 10 gram of a glucose or 10 gram of a sugar is a saturation amount for a 10 ml of water. So 10 gram is the concentration which saturate complete at room temperature to the water. If I am going to add 5 gram, then it is unsaturated solution. So clear? Now 10 gram is saturated solution, 5 gram unsaturated solution, and if I am going to increase a temperature of water, 10 ml water by 2 or 3 degrees Celsius, then definitely there will be an increased solubility of sugar, say 11 gram. Now 11 gram is become super saturated solution, and after just cooling down that test tube or beaker, it shows the crystallization. So this is a diagrammatic representation. Any solution can be made saturated or unsaturated or supersaturated by changing the temperature. So temperature plays a very important role in the solubility aspect. Let us consider over here a solute of say 100 gram. In that axis, if we move from x axis, then it shows there is a increase in the temperature, this increase in the solubility, and this axis represent the saturated solution. Above that axis there is a supersaturation, and below that curve there is a unsaturated point. So it can be very well explained with this diagrammatic representation. This shows that as the temperature increases, the solubility per 100 gram of H2O increases, or solubility of per 100 gram of water increases. Okay, as soon as this is the saturated point, as soon as I decrease the temperature from this particular location, this particular point, if decrease in temperature, the concentration remains in solution, this becomes supersaturated. Okay, so this is all about saturated, unsaturated and supersaturated. Now moving toward the next, this is the how solute and solvent interaction take place. Let us consider this is breaking of solute bond to permit the removal of solute molecule from the solid state. This is definitely, solute is a solid state, that is there is a breaking of AA, or this is this solute with this solute, and this is like look like this one. After that, when this is delta H1, that is this enthalpy change. Now to accommodate this solute molecule in a solvent molecule must create a vacate or empty space, so that, or void space, so that this solute can incorporate into the solvent. So this is nothing but the second state, that is spread out of solvent. This is first state, spread out of solute. And after that, if this solute and solvent interaction is much more stronger, then definitely the solute molecule goes into the void spaces which is created by the solvent, and there is a solute solvent interaction. So total change in enthalpy is nothing but, that is delta H of solution formation is nothing but delta H1 plus delta H2 plus delta H3. This is nothing but enthalpy change of solution, which is refers the overall amount of heat which is released or absorbed during the dissolving process of the. Very common example I am going to say, in a chemistry, organic chemistry lab, if you are trying to dissolve what we say NaOH dissolve in a water, and there is an increase in the temperature of that content. So this will act as a exothermic reaction because heat is evolved. And if you try to dissolve sodium, calcium chloride, potassium chloride, so this, when we dissolve this in a water, they absorb the heat from the surrounding, that is from beaker, and beaker somehow feel colder than the previous one. So this is endothermic reaction. So depending on the enthalpy of solution can either be positive, that is endothermic, or negative, that is exothermic. So the enthalpy of solution is commonly referred as delta H of the solution. So this diagram hopefully I cleared. Till now we have just seen, I am going to again revise you. We have just gone through a concept of solution, in that some definition of solution. After that we have gone through a solubility. Solubility is quantitative and qualitative way. Then on different factors the solubility depends. Then thermodynamic solubility. In thermodynamic solubility I am going to again repeat, that is the most stable crystalline form that remains in a solution in a given volume of solvent at a given temperature and pressure under equilibrium condition. Over here saturated and unsaturated solution, then supersaturated, this diagrammatic representation, this is graph, okay, and this is nothing but the, what we say, the intermolecular forces and their enthalpy change with solute and solvent and the formation of solution. Now solubility expression. So up till now there might be a question for 1 mark or 2 mark regarding the definition of solubility, solution, thermodynamic solubility. These are the some question. Define solubility qualitatively or quantitatively with example. What do you mean by thermodynamic solubility? Okay, so this might be the question, and this is the question for 2 mark, solubility expression. Solubility expression, it is very well explained according to United States Pharmacopoeia. That is, if we want to express the solubility, there are so many ways to express the solubility, but the United States Pharmacopoeia describes the solubility of drug as a parts of solvent required for 1 part of solute. That means if I am using 1 part of drug and try to dissolve in a solvent, so for that 1 part of drug, how many parts of solvents are required? For considered 1 part of drug dissolve in a 1 part of solvent, this is 1:1. 1 part of drug dissolve in a 10 part of solvent, this is 1:10. Likewise, so this is very well explained by the USP. Not only this, if we am again move further, then European Pharmacopoeia also list this category. So there is one, there are 7 categories in USP, that is these are very soluble, freely soluble, soluble, sparingly soluble, slightly soluble, very slightly soluble, and practically insoluble is given in USP, but it is not given in European Pharmacopoeia. So these are the certain expression. Now apart from that, these are the USP expression. Apart from that, you can express the solubility in a molar concentration, that is 1 molar NaOH. For 1 molar, you know the molecular weight of NaOH is 40, and 40 gram in 1000 ml of a water is 1 molar. So 1 molar. Apart from that, molar solution, even mole fraction, percentage by weight, percentage weight by volume, and percent by volume. So these are the ways which how we can express the solubility, and the question may be for 4 marks or 5 marks in your examination. According to new PCI pattern, the question may be for 5 marks regarding the solubility expression. So you need to pen down all these quantitative way and qualitative way. So usually USP defined in a 1 parts to 100 parts or 1 part to 1000 parts. So this is qualitative way, and these are molar, molal, mole fraction, percentage by weight. This is all about quantitative way. So this is next to this one table is given, that is very soluble is the drug that required 1 part in less than 1 part of solvent. Freely soluble drug required 1 to 10. Soluble drug required, that is 1 part of a drug required 10 to 30 part of solvent. Sparingly soluble required. This is according to USP. So this is very important. There might be a question in your GPAT examination that is slightly soluble required 100 to 1000 parts of solvent or 30 to 100 parts of solvent, likewise. So be careful about this table. Moving toward the next, quantitative, that is USP expression, number of, that is we have already discussed, number of mLs of solvent dissolved 1 gram of solute. Molar solution, molal solution, molar and molal, there is a difference. Molar is for 1000 ml or 1 liter, and molal is for 1000 gram or 1 kg. Mole fraction, percentage by weight, percent weight by volume, likewise. So this is not given in your syllabus, the biopharmaceutics classification system, but I found it is very important for you. So just brief, the entire drugs are classified into 4 classes: class 1, class 2, class 3 and class 4. The class, and in that axis there is a permeability, and on that axis there is a solubility. So on y-axis there is a permeability, and on x-axis there is a solubility. So the drug comes in a class 1 having a high solubility as well as high permeability, rapid dissolution. So these drugs are very, that means we need not to work more on these drugs because they are easily soluble and easily absorbed. These drugs having a low solubility and high permeability. So this is the major area for solubility improvement, class 2. Class 2 is low solubility and high permeability. Class 3 is high solubility but low permeability. So over here we need a penetration enhancer, permeability modifier. So this is the area. In class 4 we have a very less chance to work, that is because they are having a low solubility and low permeability. Both are required, that means solubility and permeability, for absorption or viability. So this is all about biopharmaceutical classification. Though it is not included in your syllabus, I found it is important, that's why I included over here. Now this is important. This is again the question for 5 marks. Mechanism of solute and solvent interaction. So in next lecture we are going to cover the mechanism of solute and solvent interaction. Till then be at home because we are facing a pandemic situation. So safe, and if you found the video is important, then please subscribe my channel. Definitely I am going to include such videos entire on a physical pharmaceutics. So thank you.